It would be just as easy to build a fence around Spanish Town Square if we knew the total distance around it. In fact, this is quite easy, as Spanish Town Square is actually a square. How would we do that? Let's say the sides measure 100 meters. Since it is a square, it means that all four sides are equal and therefore measure 100 meters each. The perimeter, being the total distance around the shape, suggests that we add all four sides, so the perimeter would be 400 meters. We can use our calculation to derive a formula for the perimeter of any square. Since the length of all the sides are the same, we can represent the length of one side using the letter L. Therefore, 4 equal sides suggests that the perimeter would be equal to L plus L plus L plus L, which is 4L. So the formula for the perimeter of a square is L plus L plus L plus L, or 4L. A similar formula can be derived for the total distance of a shape that is not a square. A football field is rectangular in shape. Its length measures about 110 meters and its width 75 meters. How would we find its perimeter? Remember, the perimeter of a shape is the total distance around it. Since this is a rectangle, we know that there are two pairs of equal sides. So the perimeter would be found by adding 110 meters plus 75 meters plus 110 meters plus 75 meters, which would give us 370 meters. Since the rectangle has two pairs of equal sides, represented by the length and the width, if we were to derive a formula based on the calculations, the perimeter would be equal to L plus W plus L plus W, which is the same as 2L plus 2W. So how would you measure the perimeter of this fenced area? There is no formula for this irregular figure, so you would just have to add the length of each side. Remember though, that the perimeter of any shape is found by adding all the sides of the shape, no matter what the shape is. Now, is there any shape that you can think of for which it would be difficult to add the sides to determine the perimeter? The one that springs to mind is the circle. The perimeter of a circle is usually called its circumference, which is the same as the total distance around it. There is a simple formula for determining the distance around any circular shape. If we were to measure the distance around a circular shape, such as a glass cylinder, and then measure its diameter and divide them, we would get approximately 3.142. As a matter of fact, if we did this for any circular shape, we would always obtain a value close to 3.142. This value is called pi and is a constant. So in all cases, the circumference of any circular figure divided by the diameter gives us pi. If we were to make the circumference the subject of the formula, it would be equal to pi times the diameter. And this is how we find the circumference or perimeter of any circle. Of course, since the diameter is the same as 2 times the radius, an alternative formula for the circumference is 2 times pi times radius. If a circular tablecloth has a radius of 28 centimeters, what is the total length around it? Since its radius is 28 centimeters, then its circumference would be approximately 176 centimeters. And if the face of a circular clock has a circumference of 44 centimeters, what is its radius? This would be 7 centimeters. Did you ever notice that when people are buying a house or land, they always make reference to the land in square meters? Well, square meters refer to the area of the land. What is area? Area refers to the surface or region enclosed by a boundary. For example, when we buy a piece of land, it is within a boundary. If there is a house on it, the house itself occupies a specified region. This region is its area. How do we find the area of a shape? Remember, it's the region within a boundary. Let's take a ramp, for example. It forms a right-angled triangle with the ground. Let us say that the height of the ramp above the ground is 2 meters and that the distance of the bottom of the ramp from the wall is 3.5 meters. What would be the area of the triangular side under the ramp? The area of a triangle can be found by the formula half base times height. So the area under this ramp would be half of 3.5 meters times 2 meters, which is 3.5 meters squared. Please note that area is given in meters squared. In some cases, the height of a triangle is not readily identified. In such cases, we use Heron's formula, also known as the semi-perimeter formula. Please note that A, B, and C in the formula represent the sides of the triangle, and S is the semi-perimeter. For example, a triangular garden plot has dimensions 5 meters, 6 meters, and 7 meters. Picture it to have the shape of a scalene triangle. First, we find the perimeter of the triangle, which is 18 meters. Then, as the name semi-perimeter suggests, we divide the perimeter by 2, which gives us 9 meters. We then substitute this value along with the sides into the formula to find the area. So the area of the plot would be approximately 14.7 meters squared. Let us go back to that football field I mentioned before. Previously, we found its perimeter, but what if we wanted to know its area? Again, remember it's the region within the boundary. So the area of the field would be found by multiplying its length by its width. Therefore, the area of the football field would be 110 meters times 75 meters, which is 8,250 meters squared. Also, the area of the square in Spanish Town can be found in a similar manner since it has a similar shape as the football field. Therefore, the area of the Spanish Town Square would be 100 meters times 100 meters, which is 10,000 meters squared. We applied the same method to find the area of the Spanish Town Square, but notice that in this case, the length is the same as the width. Of course, that is because it is indeed a square, and so instead of using length times width, we use length times length as the formula. Consider a parallelogram. We know that opposite sides are parallel and equal, but that also seems like a rectangle. However, the difference between the two is that in a rectangle, all interior angles are equal, whereas in a parallelogram, only opposite angles are equal. This means that to find the area of the parallelogram, we use its base and its height. The formula for the area of a parallelogram is base times height. This comes from the fact that the parallelogram consists of two congruent triangles. Congruent means equal in size and shape. We know that the area of a triangle is half base times height. So if there are two triangles, the total area would be half base times height plus half base times height. Half plus half is equal to 1, so the total area, which would equate to the area of the parallelogram, is base times height. For example, what would be the area of a parallelogram with a base 5 centimeters long and a height of 4.5 centimeters? Its area would be 5 centimeters times 4.5 centimeters equals 22.5 centimeters squared. A rhombus is a special kind of parallelogram. What makes it special is that though it has the properties of a parallelogram, all its sides are equal. However, it is still treated like a parallelogram. So if we want to find the area of a rhombus, we use base times height. What is the area of a rhombus whose sides measure 5 centimeters and height measures 4 centimeters? The area would be 4 centimeters times 5 centimeters, which is 20 centimeters squared. A kite is another shape whose surface area we might be interested in knowing to estimate how much kite paper is needed to make it. The area of this kite can be easily derived using a formula. In finding the area of a kite, we use its diagonals. So, if we wanted to know the area of little Johnny's kite, whose diagonals measure 50 centimeters and 35 centimeters, we multiply the diagonals 50 centimeters times 35 centimeters and divide by 2, which would give us an area of 875 centimeters squared. To derive the formula for calculating the area of a circle with radius r, we cut a circle into 4 equal sectors. Arrange the 4 sectors in a row, alternating the tips up and down to form a shape that resembles a parallelogram. The reason for changing a circle into a parallelogram is because we don't know how to calculate the area of a circle yet. We transform a circle into a shape whose area we know how to compute. The length of the bumped base, the base with the arcs, is equal to half of the circumference of the original circle, and the length of the other side is equal to the radius r. In changing the shape, no area has been lost or gained, so that the area of this newly formed parallelogram is the same as that of the original circle. However, this parallelogram has arcs on both its top and bottom, so we still don't know how to calculate its area. To solve this problem, we cut the original circle into a greater number of equal sectors. As we increase the number, the arcs become smoother and the parallelogram looks more and more like a rectangle. As the number approaches infinity, the bumped parallelogram with the arcs becomes a perfect rectangle with its width equal to pi times r and its height equal to r. As illustrated earlier, The width of this newly formed rectangle equals half of the circumference of the original circle, and the height is equal to the radius r. As a result, the area of the circle equals the area of the rectangle, which is pi times r times r. This is equal to pi r squared. So, if we wanted to know the area of the surface of a circular table whose diameter is 70 centimeters, we first find the radius, which is 35 centimeters, and then the area would be 22 over 7 times 35 times 35, which is 3,850 centimeters squared. What if we had a cake with a radius of 14 centimeters? How would we find the area of the top of the cake? The area would be 22 over 7 times 14 centimeters times 14 centimeters, which is 616 centimeters squared. How would we find the area of the top of a slice of the cake if it is divided into 4? To find the area on top of a quarter of the cake, we would simply divide by 4, which would give us 154 centimeters squared. That concludes the first part of mensuration. Join me again for part 2, where we will look at measurement in three-dimensional objects. The objective of solving an equation is to find a value which makes the statement true. For instance, if we are solving the equation x plus 3 equals 5, what we are really being asked to do is find a numerical value for x which makes the statement true. In order to do this, we have to have all the variables on one side of the equation and the numbers on the other side. A variable is a symbol that represents a number. Usually, we use letters such as n, x, or t for variables. Solving an equation can be compared to balancing a scale. The first thing you need to do in solving an equation is to decide which is the number side and which is the variable side. Looking at our equation x plus 3 equals 5, the number side is clearly identified as there is only one number there. However, on our variable side, there are both variables and numbers, so we need to remove the numbers. Since we are adding 3, in order to remove it, we do the opposite. We subtract 3 from the left-hand side of the equation. In order to keep the equation balanced, which we must do, we take 3 from the other side. Since we have removed 3 from both sides of the equation, we are left with x on the left-hand side and 2 on the right-hand side. This means that x is equal to 2. Let's look at another example. If we add 7 to 3 times a number, the result is -2. What is the number? First, we form an equation which is 3x plus 7 equals -2. On the left-hand side, we need to get rid of the numbers. We are adding 7, so to remove it, we subtract. Of course, what we do on one side, we must do on the other. So we also subtract 7 from the right-hand side of the equation. When we do this, we are left with 3x on the left and -9 on the right. However, we have not fully solved the equation until the coefficient, that is, the number in front of the x, is equal to 1. Since on the left side our variable term is 3x, which means 3 times x, we divide by 3. And as usual, What we do on one side, we must do on the other. So we also divide negative 9 by 3. So the solution is x equals negative 3. We have now solved the equation. In the equation 2p plus 5 equals 7p minus 10, there are variables and numbers on both sides of the equation. When this occurs, we deal with each side separately. In these cases, you must clearly decide which side is the variable side. In this case, we will deal with the left side first. So first, we subtract 5 from both sides. We now have 2p equals 7p minus 15, which means the left-hand side only has variable terms. We now have to deal with the right-hand side in the same manner. Subtracting 7p from both sides leaves us with negative 5p equals negative 15. Since our aim is to find the value of p, we divide both sides of the equation by negative 5 so that the value of p is 3. Let's now take a close look at fractional equations. Just as with regular fractions, once we add and subtract, we must find the LCM of the denominators of the fractions involved. For instance, in the equation a half plus a quarter equals x over 12, we need to determine the value of x. First, we find the LCM of 2, 4, and 12, which is 12. Then, we multiply each term in the equation by 12. This gives us 6 plus 3 equals x. Our numbers are already on one side and our variable is on the other side. So we can now determine that x equals 9. Let's look at another example. 3 over 2y plus 2 over y equals 5. The LCM of 2y and y is 2y, since it is the lowest term that both denominators can divide into. Again, we multiply each term by the LCM, giving us 3 plus 4 equals 10y. 7 equals 10y. Dividing both sides by 10 makes y equal to 7 over 10. Sometimes the fraction has more than one term in its numerator. For example, x plus 3 over 2 plus 2x plus 2 over 3 equals 3. Just as before, we find the LCM of the denominators, 2 and 3, which is 6, and we multiply each term by it. This allows us to get rid of the fractions. We now have next, we group the like terms to give. Can you solve for x? Yes, we can get a fraction for an answer. So now we know how to solve simple equations, even those with fractions. What do we mean by total surface area? The total surface area of a three-dimensional object refers to the sum of the areas of all the surfaces of the solid. Suppose we wanted to know the area of a die whose edges are 10 centimeters. Of course, we know that the die is actually a cube. We also know that the cube has 6 faces, each one in the shape of a square and therefore equal. So to determine the area of the die, we need to find the area of one face and multiply by 6 to get the total surface area. Since the formula for the area of a square is length times length, or length squared, the total surface area of the cube would be 6 times length squared. And so to find the area of the die, we would get 6 times 10 squared, which would give us 600 centimeters squared. Suppose we already know the total surface area, but need to find the length of one edge. For instance, the area of a jewelry box is 384 centimeters squared. This jewelry box is in the shape of a cube. What is the length of an edge? Since there are 6 equal faces, we first divide the total surface area by 6 to get 64 centimeters squared, giving us the area of one square face. Then, to find the area of one face, we find the square root of 64, which gives us a length of 8 centimeters. But what would be the total surface area of a shoebox whose dimensions are 15 centimeters by 20 centimeters by 35 centimeters? The shoebox, like the die, has 6 faces. However, the faces are not all equal. Only opposite faces are equal. So if I find the area of the top face, it would be equal to the bottom face. The area of the front face would be equal to the area of the face at the back, and the 2 side faces would be equal to each other.